Amortization schedule. Under an amortized loan, each repayment contains a portion for interest and a portion to repay part of the principal. However, the portion for each varies with each repayment, although the overall repayments remain constant. In the early repayments, the interest portion is large, while in the later repayments, the principal repayment portion is large. The diagram below shows this. So the repayment amount stays the same. So the mortgage repayment every month is the same. But at first, you're mainly paying off interest. So that's why the orange curve, interest, is very high at the top and then gradually it gets lower. And initially, you're only paying a very small amount of the principal. So you're only paying a very small amount off your actual bill. But that blue curve gets bigger. So by the end of your mortgage, so for example, if we imagine that this is 30 years, you're paying mainly your principal, mainly your own bill, and very little amount of interest. For an amortized loan, we can construct a schedule showing how much of each payment is interest and how much is principal. This is called an amortization schedule. This schedule can be constructed manually by working on a year-by-year basis, as example 3 shows. Alternatively, the schedule can be constructed using software packages such as Microsoft Excel. The reasons for constructing an amortization schedule include the fact that for businesses, the amount of interest paid on a business loan in a given year can be offset against the tax due for that year. Early repayment of an amortized loan. Suppose Mary has taken a 20-year mortgage to buy her apartment. After 14 years, she inherits a sizable sum of money and wants to pay off the remaining mortgage. How much will this cost her? Again, there are many ways of calculating this amount. Perhaps the easiest way is to find the equivalent value, taken at the time she wants to pay off the mortgage, of all her remaining payments. However, if we have an amortization schedule, we can read off directly how much she needs to pay after 14 years to clear the mortgage. So here we have example 3, which shows examples of this. Serena borrows €50,000 from a bank to fund new machines for her business. She agrees to repay the loan plus interest by a series of level annual repayments starting 1 year later and continuing for 6 years. The agreed annual interest rate for the loan is 7.5%. Part 1. Find the amount of each annual repayment. So we're going to use our formula from page 31 of the formula book, which is our amortization formula, which is A is equal to P times I times 1 plus I to the power t divided by 1 plus I to the power t minus 1. P is going to be 50,000, so we swap the P for 50,000. T is going to be 6 to the power of 6, so we swap both those t's for 6. And I is 0.075, so we got that from here, 7.5%. So you swap each of those 3 i's for 0.075. Into the calculator, and we get €10,652.24. Thus, her equal annual repayment will be €10,652.24. Part 2. Construct a schedule showing the interest and principal portions of each of Serena's annual repayments. So there's 6 steps involved, and I'm going to go through each of them one by one. So step 1, enter the amount borrowed as the balance on the first line. So she borrowed €50,000, so the balance, we start off with €50,000. Let's have a look at the columns we have. Column 1 is the payment number. So we start off with 0 and we go up as far as 6 because she's borrowing for 6 years. Column 2 is going to be the fixed payment. Column 3 will be the interest. Column 4 will be the principal. And the last column will be the balance. Step 2. Enter the fixed payment calculated above in each space for the first payment to the last. So we worked out in part 1 that this was what her fixed payment would be annually. So we just write this amount in along every row of this column. So we got this from part 1. Step 3. Now fill the table in row by row. In each row, calculate the interest by multiplying the balance from the previous row by I, i.e. calculate the simple interest for 1 year. For example, for payment 1, the interest will be €50,000, which was the balance, multiplied by 0.075, which is the interest, 7.5%, which gives us €3,750. So that's the interest. For payment 2, the new balance is now €43,097.76. This is the new balance. We got this because we said 50,000, which was the previous balance, take away €6,902.24. So take away the principal, leaves us with the balance. And we got the principal because we subtracted the interest from the fixed payment. So €43,097.76 multiplied by 0.075 gives us €3,232.33. So that's the new interest amount. Part 4. To find the principal portion in each row, just subtract the interest from the fixed payment. Example for payment 1. Payment 1. The principal will be €10,652.24 minus €3,750 equals €6,902.24. Part 5. To calculate the balance, we subtract the principal amount from the previous balance. For example, for payment 1, the balance will be €50,000 minus €6,902.24 equals €43,097.76. Part 6. This table is self-checking. If the values are correct, the last balance should be 0, or just a few cents on account of rounding. So we end up with 0, or close to 0 at the very end. Part 3. At the end of 4 years, Serena finds herself in a position to clear the loan. How much will she have to pay the bank at this stage to clear the loan? From the table, each payment occurs at the end of that particular year. Thus, the balance still owing at the end of year 4 is €19,126.80. So this is year 4, and this is the balance that's left. This is what she will have to pay to clear the loan at the end of year 4. So just to summarise the steps again, we start off with the balance, €50,000. We get 7.5% of that, and that's going to be the interest, $3,750. We subtract this from the fixed payment to leave us with the principal. And to get the new balance, we take the previous balance, subtract the principal, and that gives us the new balance. Then we start again. We have the new balance. We get 7.5% of that, and that gives us the new interest. We subtract that interest from the fixed payment, and that gives us the principal. And then to find the new balance, we take the previous balance, subtract the principal, and that gives us the new balance. And we continue on until we get to the end, and we should end up with 0.